So in this video, we're going to be talking about some other ways that we classify polynomials, specifically by their degree, but then also by their leading coefficient. The degree and the leading coefficient tell us a lot about graphing when we get to that with polynomials. So the first one is this idea of the degree. The degree is pretty easy to find when something's in simplified form. And what I mean by that is that it's just terms being listed. So if you watch my other video, all of those examples that we saw there. When it's in simplified form, so everything's already multiplied out as terms being listed, the degree is simply the largest exponent on the variable. We use this as a large classifier of what type of polynomial we're looking for. So if your degree is 1, which means that your highest exponent is just x to the first, then this is known as a linear polynomial. If your degree is 2, which means that your highest exponent on your variable is 2, then this is quadratic. The next one is 3, so you have an x cubed. This is actually known as cubic. And the last one with its own fancy name is x to the fourth, which is known as quartic. After that, it is simply whatever degree it is. So if I had something that was x to the 8th, I would just say this is an 8th degree polynomial. So let's go and actually practice finding the degree pretty quickly. So here I have 4 polynomials. Because these are all just list of terms, I'm simply looking for the highest exponent on each of them. Looking across here, I see that it's 5. I can keep going here. My largest exponent is 8, 4, and here it's actually this one, and that's a good reminder that if you don't see anything written, it's really a 1. And so those are our degrees. We use our new terminology. We know that this one is in linear, and you should be able to identify that as y equals mx plus b, that kind of form here. And we know that is a line. And then this one might be new, but this is quartic because the degree was 4. So that is how we can find them in standard form, in simplified form. But sometimes they're given to you in factored form, and so we need to be able to figure out what are the degrees of all of these as well. And so one way that you could do it is you could do all of this multiplication out to put it into simplified form, and then you can see what that highest exponent is. But that takes a lot of work, and we don't have to do that. One of the alternate definitions of the degree is when it's in factored form, the degree is actually the number of linear factors. So linear, once again, meaning that it's just x to the first inside of that factor itself, and then it's how many of those do we have. So let's look at that. Here, this is 3 to the x is linear, 2 to the x is linear. There's only one of these, because it's only to the first power. This is to the second power, so I know that there's actually 2 of these. So there's 1 here, 2 here, for a total of 3. This would be cubic. There's 3 of them. Coming to the next one, these are all linear because inside of my parentheses, the highest exponent I see is just x to the 1. There are 2 of these. There are 5 of these, and there's 1 of these. So 2 plus 5 is 7. 7 plus 1, this has a degree of 8. Coming down here, this 3 in the front might throw some people off. But because there's no x, when I'm dealing with the degree, it doesn't matter. There's not an extra x there. It's not going to impact how many exponents are my x when I multiply it all the way out. For these, even though these two have a square root, it's not on the variable, and so that is okay. The variable for each of these is still x to the first, so we're just saying how many factors are there. This one has 2. There's 1 of these, 1 of these. This one has 4 total, so this is a quartic. Looking at our last one, this one's slightly trickier. This one's still x to the first, which is great. This one is linear, and there's 3 of them. But when I come here, I see x squared. That does not mean that I stop and say there's only 3. I need to use my prior knowledge that says, hey, anything that is x squared actually factors down further. And because it's squared, it actually factors down into two linear factors. I know that to be x plus the square root of 8 and x minus the square root of 8. If you're not sure how I got that, you can watch the next video on factoring. But that gives me 1, 2, 3, 4, 5. This has a degree of 5. So once again, if it's in factored form, we count up how many linears, and sometimes we have to go a little bit deeper here as we did here and recognize that if it's not linear already, how could we break it down more? If it's in simplified form, which we like, it's just that highest exponent. The next thing then is the leading coefficient. The leading coefficient is a little misleading in its title because it's not always in the front. What's more important is that the leading coefficient is the coefficient that is multiplied to the variable with the largest exponent. So in simplified form, it's simply the coefficient that is multiplied to your degree. So for each of these, we already found the degree. To find the leading coefficient, all I need to do is say, hey, what was multiplied in front? I already found the degree. What was multiplied in front? I already found the degree. What was multiplied in front? I already found the degree. What was multiplied in front? So it's that easy. We need to look over here in factored form as well, though. And with the leading coefficient, once again, we could multiply everything out. But if it's in factored form and we're talking about graphing, often all we care about is the sign of the leading coefficient. Is it positive or negative? And that's typically found in the very front of your factored form. So here, in the very front, there's a negative, so this one's negative. There's nothing here. Well, the opposite of a negative is a positive. This was positive 3, so that's positive, and this was negative. So if you have something in simplified form, your leading coefficient is attached to the term that gave you your degree. So you have to find your degree first, and then it's the coefficient that goes with it. If you're in factored form, we really just care about what's in the front. So let's talk really quickly about why it is called the leading coefficient. And that has to do with this idea of standard form. All of these are in simplified form. Simplified form meaning that it's just your list of terms. Everything's already multiplied out. But the order of the terms doesn't have any order. In standard form, they do have order. In standard form, we take all of those and we list our terms from the largest exponent to the smallest exponent. So we list it from the largest exponent to the smallest exponent. Let's do that really quickly here. This was my largest, so negative 6x to the 5th. Next would be negative 8x cubed. Then I have positive x squared. Then I have 4x. Then I have 10. So taking these same terms and simply listing them with my exponents going down. When you do that, your term with the degree and your leading coefficient are in the front. And that is why it's actually called the leading coefficient. It's because in standard form, it is there in the front for you. So this is how you can find the degree and the leading coefficient, and then also some of the basic vocabulary we use based on the degree itself.